So we will continue with the MCQ number 3 today. We are given that the copper sulfate is prepared by adding the excess copper carbonate to sulfuric acid. Why is an excess of copper carbonate added? To ensure all the copper carbonate has reacted, to ensure all the sulfuric acid has reacted, to ensure the to increase the rate of the reaction, or to increase the amount of copper sulfate that is produced.
It is to B, to ensure all the sulfuric acid has reacted.
Yes, very good. Correct option is option B. Okay. Okay, then we are given that which substances they react with dilute sulfuric acid to form a salt that can be removed from the resulting mixture by filtration. Aqueous barium chloride, aqueous sodium hydroxide, copper, or copper carbonate.
Aqueous barium chloride,
What are we actually looking for?
insoluble.
Yes, very good, excellent. We are looking for an insoluble salt. So which of these will give us an insoluble salt?
Aqueous barium chloride.
Option A. Very good. Okay, then we are given an aqueous solution. It reacts with a solid. The products are an alkaline gas, a water, a salt, and water. What are the aqueous solutions and the solid? The aqueous solution is sodium hydroxide, and the solid is magnesium carbonate, hydrochloric acid, or the magnesium carbonate, hydrochloric acid, or and ammonium chloride, or sodium hydroxide and ammonium chloride.
D.
Sodium hydroxide plus ammonium chloride. This one?
Yes.
What's the reason?
Because reason is like ammonia after the the ammonia gas is produced and ammonium salt reacts with a strong base. And
Yes,
like
very excellent, because it will give us an alkaline gas, which is ammonia. In option A, when we react sodium hydroxide and magnesium carbonate, it will only produce carbon dioxide. When we react hydrochloric acid and magnesium carbonate, in that case, which gas is being produced? Again, carbon dioxide. And when we react hydrochloric acid and ammonium chloride?
hydrochloric acid and ammonium chloride, we get carbon dioxide.
No, there won't be any reaction. What's the reason? Because both of them, they contain the chloride ions. Hydrochloric, it contains the chloride ions, and ammonium chloride also contains the chloride ions. So they won't react. From here we will get carbon dioxide, and from here we will also get carbon dioxide. There will be no reaction. And option D will give you alkaline gas, which is ammonia. So option D is the correct option. Okay, then we are given that copper sulfate, it is prepared by adding the excess copper carbonate to sulfuric acid. Why is an excess of copper carbonate added? We
did this question.
Yes. So the correct option
is B.
B. Very good. Which method produces the salt copper carbonate? Add the copper oxide to water, then add excess aqueous sodium carbonate, filter off the precipitate. Add copper oxide to dilute sulfuric acid, then add excess aqueous sodium carbonate and filter off the precipitate. Add copper to dilute hydrochloric acid, then add the aqueous sodium carbonate and filter off the precipitate. Add copper oxide to aqueous to excess aqueous sodium carbonate and filter off the precipitate. Which of these methods produces the salt copper carbonate?
It is copper carbonate.
Yes.
Miss, can you hear me?
Yeah, yeah.
Okay. Mine is writing 19. Okay, it would actually B, add copper dioxide to dilute sulfuric acid and add excess aqueous sodium carbonate, filter of the precipitate.
Adding copper oxide to dilute sulfuric acid, then add excess aqueous sodium carbonate and filter off the precipitate. Very good. And how did you find the correct answer?
Because like copper dioxide to like sulfuric acid, the copper it creates a copper sulfate solution. So
Yes.
and then adding aqueous sodium carbonate to that sulfate copper sulfate trigger the precipitation reaction.
Yes, very
Sorry.
good. Excellent. Okay, moving forward, we are given that copper sulfate, it is formed by reacting the excess solid copper carbonate with dilute sulfuric acid. Which processes are part of the preparation of solid copper sulfate? Crystallization, distillation, filtration, and titration.
Which processes of water person
Which processes
carbon
are part of preparation of solid copper sulfate?
Is it A 1 and 3?
Very good. 1 and 3, which is crystallization and filtration. Very good. And how is filtration being used?
So like you have to there's excess of copper carbonate. So
Yes,
like we'll have like have it like sitting in the bottom unreacted. So we
yes,
must filter it to get a clear solution of it.
yes, very good. So filtration, it is required to remove the unreacted solid or the unreacted
Yes.
copper carbonate that we added. How is crystallization being useful?
It's like it lets the saturated solution cool down slowly. And then once it cools, it like the solubility decreases and like the crystals grow.
Yes, very good. Excellent. So option A is the correct option. Okay, then we are given which type of reaction is represented by the equation shown. We are given the lead ions and nitrate ions and sodium ions and iron ions. Which type of the reaction is represented by this equation? Is it an addition reaction? Is it a redox reaction? Is it a neutralization reaction or a precipitation reaction?
Um, Is it precipitation?
Very good. What's the reason?
Because like first of all, it's like the solid itself is like uh, the precipitation is like a reaction where two solutions react to form an insoluble solid. So like the solid is itself a precipitate.
Yes, very good. Excellent. You can see that it is in solid form. We are given the salt which is in the solid form. So this is a precipitation reaction and insoluble salt is being formed. Okay. Then we are given the information about some silver compound is shown. You are given the name of the compound, the formula for that compound, and the solubility of that compound in water. Which equation shows a reaction which cannot be used to make a silver salt? Silver carbonate, it's insoluble. Silver chloride is insoluble. Silver nitrate is soluble, and silver oxide is also insoluble. Looking at option A, can this first option be used to make a silver salt? This one.
Yes.
Yes.
Mm,
Yes, this is a precipitation reaction, right?
yes.
Which compound is this one? It's silver nitrate. It is
Three
it is soluble, and we have um
hydrochloric acid,
huh, HCl, which is the hydrochloric acid. When we react it, we get
silver
silver
chloride,
chloride. Yes, silver chloride. Is it soluble or insoluble?
insoluble.
Yes. So when we react silver nitrate with HCl, we get a silver salt, which is insoluble, and the name is silver chloride. So it can be used to produce a silver salt. Moving to option B, can it be used?
And we it used to make silver chloride
Yes.
it can be used
Yes, it can be used. How?
because like so like silver oxide it's an insoluble base so like adding it to nitric acid will produce a soluble salt.
Yes, very good. Because we can see we have got a metal oxide, which are basic in nature, and we react it with acid. So when we react the acids and the bases, it will give you a salt and water. So it will also give you a silver salt. Moving to option C, can it be used to produce a silver salt? This is a reaction between a metal carbonate. This is the metal carbonate that
Nitric,
we have, and we are reacting it with an acid. Which acid is this? HNO3?
nitric acid.
Yes. We are reacting a metal carbonate with an acid, and the reaction it will produce a salt, which is silver
Oh, yeah, silver
nitrate.
nitrate.
So if we can successfully produce silver nitrate, water and carbon dioxide gas will be produced as the byproducts. Looking at the option D, the last one, can it be used to produce a silver salt? We have a metal, and we are reacting it with an acid. Will it give you silver
No,
chloride? No. What's the reason?
because it's below the reactivity zero from hydrogen.
Yes, very good. Because it is silver, it is below hydrogen in the reactivity series, so it is not reactive enough to displace the hydrogen from the acid, like HCl. So this reaction will not occur under normal conditions. So this is the correct option, option D. Okay, okay, these are the last two. Then we are given aqueous ethanoic acid, it is a weak acid. Aqueous sodium hydroxide, it is a strong base. Aqueous ethanoic acid, it is neutralized by aqueous sodium hydroxide. Which statements are correct? Aqueous ethanoic acid accepts protons from hydroxide ions. The aqueous ethanoic acid used is fully dissociated into ions. The aqueous sodium hydroxide used is fully dissociated into ions. The reaction produces a salt and water.
Uh,
The first statement is aqueous ethanoic acid accepts proton from hydroxide ions. Is it correct or
No,
not?
no.
Reason?
Sorry?
What's the reason?
Is a proton donor.
Yes, very good. Because acids they donate the protons, they don't accept them. So the first one is not correct. The second statement is the aqueous ethanoic acid used is fully dissociated into ions. Is it correct? It is fully.
No,
It's a
they
weak.
only partially dissociate.
Very good, because it is a weak acid, and we know that we measure the strength of an acid by the degree of its dissociation into ions. So the second statement is also not correct. Then we are given the aqueous sodium hydroxide used is fully dissociated into ions. Is it true?
Yes,
Yes, because it's a strong base, and strong bases they fully dissociate in aqueous solutions. This is true. And the last one is the reaction produces a salt and water.
crystal neutralization. So it will then
So which is the correct option?
3 and 4. D.
Very good. It's 3 and 4. Okay, the equation for the reaction between barium chloride and dilute sulfuric acid is given. Which row shows the state symbols for this equation? Okay, you're given the state symbols for this equation. We have barium chloride and dilute sulfuric acid. Barium sulfate and HCl will be produced.
Uh, is it A? Aqueous,
Aqueous, aqueous, solid,
solid
and
aqueous.
aqueous. Very good, excellent. It's option A. Why is this barium sulfate solid?
Barium sulfate is insoluble, so it forms a white precipitate.
Yes, very good, excellent. Okay, so this is all about preparation of salts, and now we will move towards the question papers. Okay. Okay, so we are given a list of the substances. It is shown. Answer the following questions about these substances. Each substance may be used once, more than once, or not at all. State which substance. We are given the names. You are given the names of these substances. State which substance turns yellow when an alkali is added. We are given brass, calcium oxide, carbon monoxide, diamond, glucose, hydrogen, litmus, magnesium bromide, methyl orange, sodium chloride, stainless steel, thymophthalene, water, and zinc oxide. Which of these substances turns yellow when an alkali is added?
No, methyl orange.
It must be an indicator. Methyl
Methyl
orange.
orange.
Yes, very good. It's methyl orange. Okay, so this is methyl orange. What would be the effect of the alkali on litmus? This is methyl
Okay.
orange.
The litmus will turn like blue.
Very good. And what would be the effect in acid?
Red.
Very good. And what would be its effect on thymophthalene?
Um, red, blue. And alkali and colorless in acid.
Very good. Okay, and we are given calcium oxide, zinc oxide, and the substances that are related to these, like the basic amphoteric oxides, these are not the indicators, so these cannot be the options. And then we are given
Okay.
water, we are given glucose, we are given sodium chloride, These are all the neutral substances and they do not change color themselves upon the addition of an alkali. So the change of color, the substance for identifying the change of color, the substance must be an indicator. So that's why it's with
Okay.
high orange. Then we are given that magnesium is an element in group 2 of the periodic table. You have to complete the word equation for the reaction of magnesium oxide with hydrochloric acid. Yes. What do we get when we react magnesium oxide with hydrochloric acid?
Magnesium oxide and hyaluronic acid.
Yes.
We get magnesium chloride
Magnesium chloride, very good.
and H2O.
Water. Yes, very
Okay.
good. Magnesium. You have to write the names. So it's magnesium chloride and water. In part 2, you are given that magnesium oxide is insoluble in water. Choose from the list one other compound that is insoluble in water. Is it magnesium carbonate, magnesium chloride, magnesium nitrate, or magnesium sulfate? So
Magnesium carbonate.
it's insoluble in water.
Carbonate. First one.
Very good. It's magnesium carbonate. Okay. Then we are given this equation is about sulfur and compounds of sulfur. Complete the word equation for the reaction of dilute sulfuric acid with sodium carbonate. So if I react sulfuric acid with sodium carbonate, what would be the products?
Acid plus carbonate.
Yes.
Sodium
Sulfuric acid plus
sulfate
sodium sulfate. Very good.
plus uh, carbon dioxide and water.
Very good. It would give you sodium sulfate plus water plus carbon dioxide. Okay. It's water and carbon dioxide. Then we are given a few drops of thiamophthalene indicator. They are added to dilute sulfuric acid. You have to state the color of the solution.
Sulfuric acid. It will be colorless.
Very good. It would be colorless. Okay, moving forward, we are given the figure. It shows the displayed formula of mezaconic acid. You have to complete the word equation for the reaction of ethanoic acid with magnesium. I guess the questions are skipped. I think so. Okay, anyhow, you have to complete the word equation for the reaction of ethanoic acid with magnesium.
Um, um, Magnesium methanate and hydrogen.
Very good. This is a metal and this is an acid. So when we react a metal with an acid, what do we get?
As acid and metal, we get like ethanoate and hydrogen.
Yes, we get a salt and hydrogen
Salt
gas
and
is produced.
hydrogen. Yes.
Yes. So it will give you magnesium ethanoate and hydrogen gas will be released. So this is okay. Then we will be given the question is about nitrogen and compounds of nitrogen. Ammonia is a simple molecule with covalent bonds. Aqueous ammonia is alkaline. Choose from the list the pH value that is alkaline. Draw a circle around your chosen
10,
answer. Very good.
pH 10.
It's quite simple. Okay. Ammonia forms an alkaline solution in water. Give the formula of the ions that is present in all alkaline solutions.
That's present formula of the ammonia. Like
Yes. Which ion is responsible for making a solution alkaline?
uh, uh, hydroxide.
Very good. What's the formula?
H minus.
H negative. Okay, choose from the list the pH value for an alkaline solution. Draw a circle around your chosen answer.
pH 13.
Yes. Okay. This question is about compounds of nitrogen. Ammonium chloride reacts with calcium hydroxide. The products are ammonia, a salt, and a liquid that turns anhydrous copper sulfate blue. You have to complete the word equation for this reaction. When we react ammonium chloride with calcium hydroxide, one of the products will be ammonia, and what are the other two products that we will get?
What am I? Calcium chloride and
Very good.
water.
And a liquid that turns anhydrous copper sulfate blue. The liquid is obviously water. When we add
Mm.
water to anhydrous copper sulfate, it will turn blue. It will turn into hydrated copper sulfate, which is blue. So it will give you ammonia plus calcium chloride and water. Okay. Then we are given that iron ore contains iron oxide. Blast furnace is used to extract the iron. From iron oxide equation, for some of the reactions in the blast furnace are shown. Equation 1 as giving you carbon dioxide. The second one is calcium oxide plus carbon dioxide. And the third one is you are reacting calcium oxide with silicon dioxide. Explain why the reaction in equation 3 can be described as an acid-base reaction.
Mm,
In equation 3, we are reacting calcium oxide and silicon dioxide, and we are getting calcium silicate. This is calcium silicate. So,
okay.
why it can be described as an acid-base reaction?
Because calcium oxide is a basic oxide and silicon oxide is an acidic oxide.
Very good, excellent. This is calcium silicate. Yes, because the calcium oxide it is a basic oxide because it is a metal oxide, and silicon dioxide it is an acidic oxide because it is a non-metallic oxide. Okay, moving forward, we are given the table, and the question is about acid bases and alkalis. You are given the table that shows the pH values of some substances. You have to define the term base. First, you have to define the term base.
Like define, it's
Yes,
like define like substance that can accept hydrogen ions in water. Like
very good. A proton acceptor, simply. You can say it's a proton acceptor. So this is a proton acceptor. What is meant by the term alkali?
it's like it's a soluble like base that dissolves in water
Very
to
good.
form
This is a type of
hydroxide.
a base, but an alkali is such a base which is soluble in water. A base that dissolves in water, simply. So it's a soluble base. Then we are given phenolphthalein, which is an indicator. State the color of phenolphthalein and sodium hydroxide and ethanoic acid.
Sodium.
Yes, it's sodium hydroxide and ethanoic acid.
It will be uh, mm,
You have to simply identify the nature of the compound. Which of
blue.
these? Yeah, for the first one, it's sodium hydroxide, which is alkali, so it would be blue, and the second one is ethanoic acid, which is an acid,
The
so it's
color is
yeah, very good. It would be colorless. Okay, using the information that is given in the table, you have to identify the substances with the highest concentration of H plus ions. Explain your answer. First, you have to look for the substance with the highest concentration of H plus ions. And then we have to give the explanation or the reasoning.
um, is
Highest concentration of H plus ions. How is it related to the pH?
HNO3.
Very good, excellent. How is it related to the pH? We know that the substance that will have the highest concentration of H plus ions, it would be considered as a very strong acid. And a strong acid, it will always have a very low pH. So the substance that is having the least pH, it has actually the highest concentration of H plus ions. So HNO3 is the substance, and we have already discussed the reasoning. HNO3. You have to name an indicator which can be used to identify the substance with the highest concentration of H plus ions.
Sorry, universal indicator.
Which one?
Universal indicator.
Very good. And what's the reason?
Its universal indicator can be used to identify the specific, uh, like uh, like the the substance with the highest hydrogen ions.
Yeah, actually, you can see that the reason is this, that unlike the other indicators, just like we use litmus or methyl orange or others or any others, they usually tells us if a substance is an acid or a base. That's it. But universal indicator, it has a range of colors. It changes the colors through a complete range. So it gives you the exact pH. So it will help you identify whether like which substance has the least pH, telling you that which of them
Okay.
has the highest concentration of H plus ions. The other ones, they only tells you if a substance it is an acid or a base. But universal indicator, they have a huge range of colors. So they keep on changing the color as the pH changes. So they help you identify the pH of a substance, which helps you to find that which substance has the highest concentration of H plus ions. So it is a universal indicator. Okay, then we are given complete the equation to show the dissociation of ethanoic acid in aqueous solution. You have to just show the dissociation of its ions. What would be the ions that we will get by the dissociation of ethanoic acid?
Acid.
Yes.
Mm,
When ethanoic acid, when it's a weak acid, so it only partially dissociates into the ions. What two ions do we get when ethanoic acid gets dissociated in a solution? This is an acid, so it will give away its H plus ions. So it will get decomposed into H plus ions and CH3COO negative ions. So it would be
oh,
H plus and CH3 COO negative. That's it.
okay. Mm,
Okay. Then we are given you have to write the ionic equation which represents a neutralization reaction between any acid and any alkali.
Neutralization.
Yes. Neutralization reaction between any acid and any alkali.
H plus and OH minus.
Um, any acid and any alkali. H plus. Very good. It would be H plus. And what would be the state?
Aqueous.
Aqueous. Very good. And we reacted with OH negative, and the state would be again aqueous. And what would be the product that we will get?
H2O liquid.
H2O liquid.
Liquid.
Good. Okay. It would be H2. Okay. And then we are given dilute nitric acid. It reacts with aqueous calcium hydroxide as shown. 20 centimeter cube of 0.010 mole per decimeter cube of calcium hydroxide. It reacts with 25 centimeter cube of nitric acid. You have to calculate the concentration of nitric acid in grams per decimeter cube. You can use the following steps. Calculate the number of moles used. You have to calculate the number of moles of calcium hydroxide used. How will we calculate that? Is this one included in your syllabus? Finding the concentrations and number of moles.
Second. Let me check after this.
What's the formula that we use? Number of moles is equals to the concentration times volume, right?
0
Like, have you learned about these formulas and in your school? And have you solved such
think
type of
so.
questions in this chapter?
I think so. I have. Let me just quickly into the thing.
Okay, so this is the formula. Number of moles is equals to the concentration. The unit for concentration, it's moles per decimeter cube times the volume. And the volume must be in decimeter cube. The units must be same. If the concentration is in mole per decimeter cube, then the volume must also be in in decimeter cube. Okay, looking at the statement, you can see we are given that the concentration is 0.0150 mole per decimeter cube, but when we look at the volume, it's 25 centimeter cube. So first we have to convert the volume from centimeter cube to decimeter cube. So how will we convert it? How can I convert 20 centimeter cube into decimeter cube?
Miss, uh, we haven't done this.
You haven't done this?
No, I just checked the password. I can't find
I
it.
guess it is not included in our chapter, in this
Yeah.
chapter, right?
Mm.
Okay, so we can skip this one for now because it includes so many formulas and proper calculations. So it is
Okay.
actually a complete different topic. So it's not a good idea that we start discussing it right now. Moving forward, we are given that lithium, sodium, and potassium, they are group 1 elements. You have to name the type of bonding in these elements.
Like, is it ionic or like that?
Yes, the type of bonding. Is it
Lithium, sodium,
ionic or
potassium.
um,
Like
metallic or
metallic.
very good? It's metallic. Reason?
Only reason is metallic bonding because like the strong attraction between the positive metal cations and like the sea of valence electrons between them.
Yes, they are all actually metals, and they consist of a lattice of positive ions that are surrounded by a sea of delocalized electrons. So we know that in all the metals they have a sea of delocalized electrons. That's why we can say that it has the metallic bonding inside it. So the type of bonding in these elements, it's metallic bonding. Moving to the next question, sodium reacts with cold water to form hydrogen gas and a solution of a strong alkali. You have to state the test for hydrogen gas.
It was lighted
The test
splint.
for hydrogen gas.
Lighted splint.
It would be lighted splint. Very good. And what would be the positive result?
Lighted splint. Splint.
Positive result means how will you
Pop
conclude
sound.
that yes, hydrogen gas was produced? It would be a pop sound. And this is simply lighted splint. Okay, you have to suggest the pH of a solution of a strong alkali.
14.
Yes, very good. 13 or 14. Any
14,
value
14.
between 11 and 14 is, you can say, generally accepted for a strong alkali. So it can be 13 or 14. Name a substance which can be used to uh, configure the pH of a solution of a strong alkali. To confirm, it's confirm. Okay. Name
Confirm
a
the pH.
substance which can be used to confirm the pH of a solution of a strong alkali.
Uh, universal indicator.
Very good. It would be again universal indicator. It additionally helps you to find the strength of a substance, whether an
Yes.
acid is a strong acid, whether an alkali is a strong or weak alkali, and universal indicator. Okay, then you have to write the symbol equation for the reaction between sodium and cold water. Include the state symbols as well. Universal indicator.
Na
Na, very good. What would be the state symbol?
solid.
Very good. This is a metal, so it would be solid plus.
H2O.
Very good. What would be the state symbol?
Liquid.
Very good. And what will be the products that you will get?
Um, sodium hydroxide
Okay, it would
and
be
hydrogen.
very good. NaOH plus hydrogen. Is it balanced?
Aqueous sodium hydroxide and gas hydrogen.
Very good. And is the equation balanced? You have to write the balanced chemical equation.
Balanced chemical equation.
Like you have to write the balanced equation. Is it balanced?
Uh, uh, no, there should be two unlike two sodium, two H2O, and
Very
two
good.
sodium hydroxide.
Very good. Okay. Then moving forward, you're given some symbol equations and word equations A to J. They are shown. You have to use the equations to answer the questions that follow. Each question may be used once, more than once, or not at all. Actually, the questions are skipped. We are given just a few parts from each paper. So each question may be used once, more than once, or not at all. Give the letter A to J for the equation that represents a neutralization reaction. Which of these represents a neutralization reaction?
Uh, B. Acid.
Very good. It's equation number hydrogen ions plus hydroxide ions. Hydrogen ions are have the characteristic of acids, and OH ions, it's a characteristic of an alkali. So when we react them, we get water. So neutralization reaction is B. Okay. Then you are given a list of gases as shown. You have to answer the following question using only the gases from the list. Each gas may be used once, more than once, or not at all. Given the name of the gas, give the name of the gas that forms an alkaline solution when it is dissolved in water.
Gas that forms the molecule. Mm,
Sorry?
ammonia.
Ammonia. Very good. Excellent. What do we get when we dissolve ammonia into
Ammonium. Ammonium hydroxide.
Very good. So this is ammonia because when you add ammonia to water, it gives you ammonium hydroxide, which is um, you can say it's if we add ammonium to water, it gives you ammonium hydroxide, which is NH4OH, and it produces the hydroxide ions in water, which will make the solution alkaline or basic. Okay, then we are given ethanol is manufactured by two methods. Method one is the fermentation of aqueous glucose, and the method two is catalytic addition of steam to an alkene. The catalysis method 2, it is phosphoric acid. Dilute phosphoric acid is a weak acid which contains phosphate ions. So what is meant by the term acid? State what is meant by the term acid.
Acid is uh, it's like it's a substance that like produces hydrogen ions when dissolved in water.
Yes, very good. You can say it's simply a proton donor.
Oh,
Proton donor, or a substance that produces the H plus ions when it is dissolved in water. Both are correct. You have to state the meaning of weak in term weak acid.
it only uh, partially ionizes in water.
Very good. Any acid that partially ionizes or partially dissociates. Partially
Mm,
ionized. Okay. You have to determine the oxidation number of phosphorus in
uh,
phosphate ions.
mm, 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 mm.
Uh, we
Is
don't
it
know the oxidation number.
uh,
Yes.
uh, is it 5
Positive 5 or negative 5?
positive?
Very good, excellent. So we don't know the oxidation number of phosphorus yet. So let's say we consider it as X. And what's the oxidation number of oxygen?
Like by multiplying
No,
uh,
like generally, what's the oxidation
two
number of oxygen?
two
It's negative 2, right? And we can see that there are 4 oxygen atoms, so their total contribution will be
or multiplied by 2
s- -2, and their total contribution would be
eight.
-8. Very good. So now if we set up the equation to get the overall charge, the overall charge, it's -3. So we know that the oxidation number of phosphorus, it's X, plus you add the oxidation number of 4 oxygen atoms. It should give you the overall charge on the phosphate ions. So it is -3. X would be -3 plus 8, and X is equals to plus 5. So this is the oxidation number. Clear?
Yes, clear.
Okay, this PDF is ended. So we will discuss the next two PDFs. One is about the preparation of salts, and the other one is about oxides in our tomorrow's class.
Okay.
Uh, when are you free tomorrow?
Uh,
In the evening
time,
hour.
same time.
Yeah, I'm asking you about the time.
6.
6. Okay. Okay, that's fine. 6 is fine.
Mhm.
Okay, take care. Allah Hafiz.
Allah Hafiz.